Okay. First calculation is Henry's law. Now, you tell me if this makes sense, okay? Are you ready? It's always important to connect with some kind of experience, yes? Do you agree, Ginny? Yeah. Has anybody ever had, I don't know, name a soda that everybody's had, Coke or Pepsi? Anybody ever had Coke or Pepsi? Raise your hand. Anybody not have it? Okay, you're all, no? Everybody's had it? Okay. Now, think back. They're big bottles, aren't they? Especially the 2-liter ones, right? So you take the 2-liter ones off the shelf at the supermarket and you put it in your carriage. Correct? Are you with me? Yes or no? Okay, good. And describe how that bottle feels. Describe how that bottle feels. Somebody. Anybody. What is it? Well, it's not refrigerated. You're just taking it off the store shelf. It's what? It's, I can't hear you.
Fat.
Fat, bloated. What else would you say? Give me another word.
Heavy.
Heavy. Okay, what else? Can you squeeze it? Is it easy to squeeze?
No.
No. So what would you say?
Hard.
Hard. Okay, good. Excellent. Yes? What would you say about the pressure? High pressure, low pressure?
High pressure.
High pressure, would you say?
Yes.
Yes? Okay, good. Okay, good. Excellent. Yes or no?
Yes.
Now, what you're going to do is, you would say the pressure's pretty high, though. I mean, I think it's pretty high, right? Okay. What do you think about the gas? Is the gas in the bottle completely dissolved? Yes or no? Well, let me ask you a question. You didn't expect that question, did you, Kennedy? Yeah, I know. You got to kind of think. Well, let me help you. May I be your auxiliary brain? Okay. Well, if something's not dissolved, you can see that something. If it's a gas, you can see it in the form of bubbles, right? But the soda's sitting on the shelf, and I can't see gas. I just see brown liquid, right? So it's high pressure, hard, heavy, fat, bloated. So I would say, so if somebody's coming up next to me, some weird guy is coming up next to me and says to me, all of a sudden says, is all the gas in that bottle dissolved? And you say, what?
Yes.
Yes or no?
Yes.
Yeah, of course. Anybody say no? Is anybody completely confused? Is this easy? Sabine? You're paying attention?
Yeah.
Excellent. I like that. She can do 2 things at once. I like it. Okay. You all right with this? Yes? So you'll say all gas dissolved. Will you say that? Can you say that?
Yes.
All gas dissolved. Okay, good. Now, I'm going to open the bottle. I'm going to take the cap off. What are you going to see? What are you going to see? I take the cap off. This is bloated, fat, heavy, hard, high pressure, all gas dissolved. Now, you're going to take that cap off. So, what are you going to see? What are you going to see? What are you going to see? Maybe some conclusions. Some things, okay? You can use this as a guide, okay? So what are you going to see? What's the first thing that comes to your mind?
Bubbles. Yeah.
Bubbles, I like that. Bubbles, I like that. I like that a lot. Yeah, good, good. Somebody follow that up with something.
No, you can compress it.
You can compress it. You can compress it. So easily. I like that. Is that like an Angola thing? Angola's on the board, man. I like it. I like it. He's thinking. He's thinking on the board. Well done. Excellent. All right, so you said easily compressed. Is that right? Okay, Team Angola, easily impressed. Does anybody want to do a little bit of an interpretive statement on what easily compressed means? Yes? Low pressure. Okay, good. Low pressure. Does Team Angola agree? Excellent. Low pressure. Excellent. Well done. All right, now. Right. What else do you see? What else? Anybody? Well, bubbles are forming, right? Maybe stuff's coming out. Why? Because the bubbles and the water are attached to one another, and that's because of what? Hydrogen bonding? Yeah, it's all hydrogen bonding, man. That's hydrogen bonding. Bubbles are coming out. Okay. So draw some conclusions. Why is gas coming out? Gas is coming out. So what are you going to say? Is gas becoming dissolved, or is gas becoming undissolved? Gas is becoming undissolved. Right? Gas is becoming undissolved. Yes or no?
Yes.
All right. Let me get a marker here. Gas is becoming undissolved. So let me ask you this. How does this sound? Stop me if you don't like it. Ginny, you're going to stop me? Alex, you're going to stop me if you don't like it. Okay, listen carefully. High pressure, a lot of gas dissolved. Low pressure, less gas dissolved. High pressure, a lot of gas. Low pressure, less gas. Does that make sense? So what's the relationship? Let me ask you this. What's the relationship between pressure and solubility? Is it direct or is it indirect? And I love it when he says it that way. He said it with an Australian accent, but he's really from Brooklyn, New York. But I love the accent. You're doing very well. You hold it so completely for the entire period. I like that. Excellent. Okay, so we could say, now we can draw a conclusion and we can make it mathematical. And we can say that, let me just remind you of something. Right? Right? Direct relationship. Right? Y equals mx. So m, a constant, equals a quotient. This is the definition of direct, right? You remember that? Right? Yes or no? Okay. Now from that, I can say P for pressure, S for solubility. Yes? What can I say? I can say S1 over P1 equals S2 over P2. That pressure is the pressure before you open the soda bottle. High pressure, high solubility, right? I lower the pressure, what do I have to do to that?
Lower.
I lower it. You get it? Let's put in some numbers, shall we? Just put in some numbers? Yes or no? Okay. 16 over 4. $16 over 4, right? I take the cap off. 2. What do I have to do to this? What's that number going to be? 8. 16 divided by 4 is 4. 8 divided by 2 is?
4.
4. So this equals some constant, right? Yes or no? Yes? And that constant could be the same system with a different set of conditions, right? And that'll be that's it. Is that hard or what? I mean, isn't that easy? Is that easy or what?
Yes.
Right? Doesn't it make sense in your everyday life? Yeah, it's easy. Now, how could I make this more complex? Talk about different types of solutes and solvents, different weird conditions, astronomically high pressures, astronomically high temperatures. I could get really funky with this, couldn't I? I could talk about I could talk about a variety of things, couldn't I? To really make it complicated. But we're keeping it simple. Where did Dorothy start when she journeyed to Oz? Where did Dorothy start when she journeyed to Oz?
Kansas.
No. They're stunned. It's like the dead parrot sketch. The guy was trying to sell a dead parrot, and the customer said, "That parrot's dead." And the guy selling the parrot, "No, he's not. He's stunned." They're stunned. Where did Dorothy begin when she journeyed to Oz? She started at the beginning.
Oh.
Laura's mocking me. I just want you to know that. Laura's mom, I'm being mocked by your daughter, okay? I just want you to know that. You think she's a sweet girl in school, but she's not, okay? Did I say that out loud? Sorry. Okay. So, shall we do a quick problem? All right, quick problem and then we're done with this. Okay, quick problem and then we're done. All right. It says, are you ready? I want you to do this auditory. You ready? You ready? It says, if the solubility of a gas in water is 0.77 grams per liter, it's 0.77 grams per liter, and it's at 3.5 atmospheres. Is it okay that we're using atmospheres? Is that okay? We'll see. Do you understand that that's the first set of conditions? Yes or no? We have a system with a set of conditions. Let me read those set of conditions again. It says, if the solubility of a gas in water is 0.77 grams per liter at 3.5 atmospheres of pressure, comma, so that's the first set, yes? It says, when its solubility, what does it say? It says, what is its, progressive lenses are difficult sometimes. What is its solubility? Grams per liter. What's its solubility in grams per liter if the pressure is decreased to 1 atmosphere? How would you do it? Set up the formula, right? Easy? Make sure that everything is the same. If you do this simple rule, you're going to greatly unburden yourself with unit labels. Grams per liter, atmospheres, atmospheres. As long as everything's the same, you're okay. Yes? And you know what you want to calculate it in, okay? These have to match. Okay? Yes? Okay. So, 0.77. Now we can leave off the unit labels, right? We've satisfied the burden of unit labels. 0.77 Don't put X. Put what you're calculating. I'm serious. Don't be afraid of letters. Letters can be your friend. Okay? Not everything is an X. 0.77 times 1 divided by 3.5 is what? Yes? 0.22?
Yes.
You telling me is 0.22? Correct? Okay. You get it? Easy? Henry's law. Is it going to get any more complicated than that? I doubt it. Will the problem become a little longer? Maybe. Easy. Yes or no? Okay. Enough said. All right. All right. Henry's law is finished. We'll do a quick molarity problem and then we're done for the day. Okay? We have 10 minutes. All right? So hold on, one more video.